Hi. In the last few sessions, we talked about VHDL concurrent statements. We talked about concurrent signal assignments. We talked about process block. Then we talked about component instantiation. Then we talked about when else statement and with select statements in VHDL. We also talked about if generate statement and for generate statement in the last session. Now let's talk about VHDL sequential statement. We are going to cover if-else statements, case statements, loops, and wait statements in couple of few videos. So the very first and most important note is that the sequential statements in VHDL can only be used inside the process block. We cannot write sequential statements directly inside the architecture body of a VHDL file. In this video, first we will talk about sequential assignment operator in VHDL, which can be used to assign values into any signal inside the process block. This statement is identical to the concurrent assignment statement, which we have seen in the concurrent statement session, right? Here is an example of a sequential assignment statement where we are assigning signal X to signal Y. But this statement is now inside the process block. Hence, this will execute sequentially. This means if this statement is outside the process block, then it will execute concurrently. But if the same statement is inside the process block, then it will execute sequentially. Okay. Although you need to learn that when you should use sequential execution and when you should use concurrent execution, because their use cases are very specific. In some cases, or in your simple designs, you may get the same results while executing your statements in any of them form. But in practice, if you do not use them carefully or correctly, then you may get either the compilation error or you may get the logical error in your VHDL designs. Do not worry, we will talk about them later in this series to tell you that when to use sequential execution and when to use concurrent execution. But first, we will talk about if-else statement in VHDL. The if statement provides a way of branching on the conditions. Here is the structure or syntax of a typical if statement in VHDL. Let me read it first. So it is if condition 1, then we have code section 1. Else if condition 2, then code section 2. Else if condition 3, then code section 3. Else code section 4. And if semicolon. So this sample code checks for the three conditions. You can check more conditions as well based on your needs just by adding more else if statements in this. The conditions involved in this if-else statements are usually written as Boolean expressions. So they are evaluated as either true or false. We will see this with some examples in the upcoming slides. So if the first condition is true, then the code written in the code section 1 will be executed. If the first condition is false, then only the if statement checks for the second condition. And if the second condition is true, then the code written in the code section 2 is executed. And if the first and second condition both are false, then the if statement checks for the third condition. And if the third condition is true, then the code written inside the code section 3 will be executed. And finally, if none of the condition is true, then the code in the code section 4 will execute. The syntax here is very similar to C or C++. But if you notice about the keywords, then they are slightly changed in VHDL. So first of all, else if. So it is not ELSEIF, it is ELSIF. Okay. So make a note of it that else if has missing E here in this VHDL keyword. Next important point is each if statement must be ended with an if statement. And the third note is there is no bracket needed to group the statements in VHDL for the code sections. Now let me tell you the most important point with the if-else statement. And it is that if-else statement has the priority in place. This means that the first condition is having the highest priority because every other condition will be ignored if the first condition is true. Similarly, the second condition has the second priority and it works in the same manner for the other conditions as well for the below the line. This means that if the first condition is true, then the statements will only execute the code in the code section 1. It does not matter if condition 2 is also being true at the same time. Means it will execute the statements inside the code section 1 and then exit from the if else block. It will not even check for any other condition there. And this prioritization is having a negative impact on the hardware generation. We will see that in some time here. But before this, let's look for this simple example. This is a 4:1 multiplexer. Here is a simple example of a typical if statement used inside a combinational process. Because this is a combinational process, means the sensitivity list must include all the signals that the process will read. So the process needs to read signal A, B, C, D, and select input. So all of these signals are going to use inside my sensitivity list at the top. Okay, so let me read the code first. So it is mux colon process select A, B, C, and D. Begin if select equals to 0, 0, then T out gets the value of A. Else if select equals to 0, 1, then T out gets the value of B. Else if select equals to 1, 0, then D out gets the value of C. Else D out gets the value of D. And if semicolon and process semicolon. So this if statement checks for the three conditions. The first condition checks if select equals to 0, 0. Then D out is assigned the value of signal A. If the first condition is false, then the second condition checks if select equals to 0, 1, and if this condition is true, then D out is assigned the value of signal B. Then the third condition checks if select equals to 1, 0, and if it is true, then D out is assigned the value of signal C. And in the last, if none of the condition is true, then the simulator executes the else section and D out is assigned the value of signal D. Okay, so this is the hardware implementation of our if statement. For this example of multiplexer, input A, B, C, and D are on the left hand side, and our output signal T out is on the right hand side. And the hardware consists of a few multiplexer and some logical gates. Note that I have color coded this according to the conditions being tested. So the red circuitry is used to realize the first condition. The blue circuitry is used to realize the second condition. And finally, the green circuitry is used to realize the third condition and also the default condition. Each multiplexer has two inputs labeled as 0 and 1. And the AND gate output is connected to the selection pin of multiplexer. So it acts as a select lines. So when the AND gate output is 0, then the multiplexer passes input 0 data to its output. When the AND gate output is 1, then the multiplexer passes input 1 data to the output. So let's look at the first condition, which has the highest priority. The first condition is realized by the red circuitry. I have highlighted the relevant signals with the yellow colors here to show you the clear picture of what is happening here. Let's assume that we meet the first condition and select is equals to 0, 0. Since select 0 is 0 and select 1 is also 0, so the AND gate output will be 1. This is because we have the NOT gate adjustment before the AND gate. And this causes the red multiplexer to select signal A and pass it to its output. Now let's take a look at the second condition, which has the second highest priority. The second condition is realized by the blue circuitry. Again, I have highlighted the relevant signal so you can see that what is happening clearly. For the second condition, let's assume select is 0, 1. And in this instance, the red multiplexer passes input 0 to the output and the blue colored AND gate output will be 1. When select equals to 0, 1, this causes the blue multiplexer to select signal. This causes the blue multiplexer to select signal B and it will pass to the output. Now let's take a look at the third condition, which has the third highest priority. The third condition is shown by the green circuitry. I have highlighted the relevant signals again so you can see that what is happening. For the third condition, let's assume select is 1, 0. Therefore, both the red and blue multiplexer select input 0 to pass to the output. The green colored AND gate output will be 1 when select equals to 1, 0. So this causes the green multiplexer to select signal C and it passes to the output. Finally, let's look at what happens when all three conditions are false. Let's assume select is 1, 1 and in this case all these conditions will be failed. Under this condition, all three multiplexer will select input 0 and it will pass through to the output. So signal T will reach to the output. So this is how the if-else statement works and how it implements in the hardware. It may be a little tricky to understand at the moment if you are completely new. But if it is the case, then I will recommend to watch this section once again because this is really important to understand for good VHDL designing, which we will be talking about in this learning series. Now I wanted to tell you another important concept in hardware designing or chip designing, and that is about timing. This is really important to understand as a VHDL designer, and this is really a great example to understand this. So the combination circuits such as logical gates and multiplexer, they do not react instantly to their input. You can visualize this from the simple screenshot on the screen. Let's look at the simple AND gate, which is having two inputs and one output. The inputs are input A and input B, and the output is C. So the timing diagram shown below here. This shows signal A going to high at some point of time, but B remains low. And then after some time, signal B also goes high. But you can see that output C only goes high after some time later of it. This is called timing delay. And this time delay is labeled as TPD in this diagram. This delay is also called logic delay or propagation delay or gate delay, etc. And all logic circuits are having this propagation delay, which means that the input signal takes some time to reach to the output, since it has to travel through the logical device or elements. Now before we move on, let's quickly recall few of the important points about the if statement. Firstly, the conditions must return a Boolean value. Otherwise, the compiler will give you some error. When any statement which has more than one condition to check, then it creates a cascade of multiplexer. Like in our previous example of multiplexer, we had three conditions. So we had three multiplexer cascaded together. If you look back at the circuit diagram of if statement, then you will see that signal A only needs to go through one multiplexer to get to the output. Therefore, signal A will reach to the output quickly compared to the other signals like signal B or C or D, as it only has to go through from a one single multiplexer. On the other hand, signal C and signal D have to go through three multiplexer to reach at the output. Therefore, the logical delay for reaching signal C or signal G to the output will have 3 times of the logical delay for signal A. And this is something the unwanted effect of using the if-else statement. However, the case statement does not suffer from this problem. So you should prefer to use case statement instead of an if-else statement whenever it is possible. And we will be talking about case statements in the upcoming session. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to our community for the regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.